Hello, this is the Captain. Welcome back to Stormworks Basics. This is the Steam Tutorial Series Part 4. And so we're going to start here where we left off in Part 3. We started out by making a diesel furnace that could run a turbine, that could run a power source, which could be converted to propeller or whatever you want to run. I then went ahead and converted those over to coal and electric. And so what we're going to do now is we're going to convert this into a piston system. So now we'll use the same electric furnace, the boiler, the condenser, but instead of a turbine, we're going to go and we're going to convert this over to steam pistons. And so first thing we need to do is start to look at some theory about steam pistons. So the first thing we need to understand is how are these steam pistons actually working inside. Now this is based off of how things work IRL to somewhat. So let's look at a cutaway and we'll see how these pistons would function inside. That's going to kind of give us some insight of how to make this work. All right, so I took those pistons and I made them a little bit of a cutaway. And so if we could see inside the pistons, this is what it would look like. So at the end of all of these shafts, we would have a plate. And we have a couple ports that go in. On this side, the steam will go in. So it'll go in here or in here on each one of these. On the other side, these are going to be steam outs. You'll see that in the editor that it will say steam in or steam out. This is what it would look like on the inside if we could see inside. This one is all the way down to the bottom, and because of that, as you can see, we have a full gap in here. So what happened was the steam came in this top valve, and it pushed it straight down like this, and it pushed the piston down. Then what happens is we would close this valve and we would let steam in here. That would push this piston up. So the steam would come in and it would fill this area as it expands, and it would push on the bottom of this plate, pushing the piston up, dragging all this linkage with it. Once it gets to the top, we're going to switch again. It's the same situation as this. It had gone up. This valve is then going to close. This one is going to open, and it's going to start the procedure over again. So it's steam in, steam comes in the top. It then shuts this valve. It then opens this valve, letting the steam come in here. And then once it's all the way to the top, it's going to shut the bottom valve, and we're going to let steam in the top to repeat the process. So that's going to walk us through. So let's go ahead and look back in the editor. If we click on these, you can set their orientation. So we can go to a minimum of -0.5. We can go to a maximum of 0.5. So you see right there, maximum of 0.5. As we do that, you can see the little ghost here will move the piston. So we're going to leave that on -0.5. This one's on -0.5, just like the illustration. This one's at -0.25, and this one is at 0. Now, if we look at some nodes here, we have these piston position nodes, and we can read those out. This will allow us to set up a microcontroller for our timing. Thing is that it's going to be a little bit different when we read out here than those numbers we had. So it doesn't go from -0.5 to +0.5. It goes from 0 to 1. And it actually makes quite a bit of sense. I'll show you how this works. And so what we're going to do here is, if you look, I have a throttle connected to an electric motor. We can actually turn these pistons with an electric motor, and we can see what they're doing in slow-mo, and that's going to make it a little bit easier for us to figure out how to set up the timing. Right, so here we are with this test rig. So let's look at the numbers first. So like I said, in the editor, it goes from -0.5 to +0.5, but in game, actually reading off of the piston position, it's going to go from 0 to 1. And so it's a little counterintuitive at first, but it actually makes a lot of sense once we get going. So this one's reading 0.5, this one's reading 0.75, this one's reading 0. All right, so let's go ahead and we're going to turn the throttle up to 0.2, and it will very slowly start to move this. So we're just going to focus on 1. So if we focus on this one, as you notice, it is increasing in number until it reaches the very top. Once it reaches the top, it's going to go from 1 to 0. And 0. Now, as it comes down, it's going to count from 0 to 0.5. So we'll notice with this first piston, here it comes. It's going to go to the bottom position, which is 0.5. It's coming back up. That's 0.5 to 1, and the cycle repeats. It seems a little counterintuitive, but it really isn't. As this comes down, it's going to be 0 to 0.5. So we want to open this inlet here. We want to let steam in when this is reading between 0 and 0.5. As soon as it reads 0.5, we want to open this valve and close this valve, let steam in the bottom. So from 0.5 to 1, we want to let steam in the bottom. Very simple. When it comes down, we want steam in the top. so 0 to 0.5. When it goes up, we want to let the steam in here. That's 0.5 to 1. And we want the opposite on this side. When this one is letting steam in, we want to let the steam back out on this side. Here's our in, here's our out. When it's coming down, as you'll see here, we want to let the steam in on this side, and we want it to come out here. So seems a little counterintuitive, but it actually makes it pretty simple and easy to do. So let's go ahead and we'll go back in the editor. All right, so here we are with the example from part 3. All I'm going to do here is we're converting this over to piston, so I'm going to get rid of the turbine. Go ahead, we'll get rid of some of this piping. We're going to have to do a bunch of new piping ourselves here. And so what we're going to do is we're going to hook up these pistons and we'll get them integrated with this generator. So we're actually going to move them off to the side just a little bit closer. So let's type in piston for steam piston, and we're going to go with the mediums. And so first thing off the bat, I'm going to press K and rotate them, and I'll show you why in a second here. They actually do not start oriented in the correct position. So if we look here, we have steam in, steam in, steam out, steam out. Now I'm just going to make sure there are at least 3 off of the condenser. Perfect. All right, so that will allow me to plug into the condenser here. So this is important to know. Your steam in needs to go in. So right here it says steam out. It's going to come out from the boiler. It needs to go into the piston. Now we're going to do 2 pistons. You can do it with 1, but often 1 piston will get stuck. Now there are ways to get it unstuck. I'm not going to go into that. You can do something like a hand crank to get it going. You kind of have to goose it, give it a crank start. You can do this pretty easily. But instead of that, we're going to do 2 pistons. I find that as good as a minimum. So again, you just put the first one in, just rotate it. But verify, this should all be steam in on this side. All right, so all steam in. Next thing we want is a valve. So we're going to grab these valves. Now, if we look here, we have fluid in, fluid out. These valves are directional. So the long side of it is going to be the out. The short side is the in. So we want to go short side towards us because we want to take the steam in from the boiler and we want to put it out into the piston, like so. All right, so we have 4 of those right there. So the next thing we want to do is I'm going to do a couple elbows on top. We're going to put a couple T-pieces on the bottom. We'll go ahead and we'll just drag these down till they are the height of where they need to come in. All right, so for this one here, it's going to be going from here through here to this one. So we'll go ahead and we will go like that. And we'll go ahead and we'll put a elbow right like that, and we'll drag across, and we'll hook this right into our boiler. So this is going to be kind of the architecture for plumbing this system up here. All right, so that is going to let steam come through. It's going to go up both sides, and these valves rather are going to allow them into the pistons. All right, good. So we'll copy one of these valves. Remember, short side's the in, long side is the out. So we want the steam out here to come out of the pistons and then go out this way. So they're going to go out the piston, in the valve, and out. All right. So we'll line these up again. So a little bit different. So we'll just do them on this side. Down, down. This one here is going to be, we'll grab a pipe, and I'll grab one of these corner sections here. That will go up like so. All right. And now this is steam out, so we don't have to necessarily do this. We could go without it. But I'm going to add it anyways. I'm just going to go a little bit of a gray color here, valve. It will work without it, but this just ensures that the flow of steam is not going to slow down our flow rates because we don't want any steam coming out of these pistons, pushing back on the steam, making it harder to get across. So this way we'll just guarantee that the steam flows in this one direction. All right, and we'll just go ahead and put a T-piece on here. And what we want to do is connect it into the condenser. So the used steam is going to come out of the pistons, and it's going to come back to our condenser here. So just line that up, and I'll put nice elbow piece. Beautiful. So up right here, I screwed up. We just need to put a pipe. We'll use this one here, T-piece corner. Use the wrong pipe. And we'll hook that up as well. So the steam is going to come in from here, across. It's going to go up, and it's going to go into these valves. Then it's going to come across here. Again, there's many ways you can set this up. I have it real close to this condenser. That's why I've used some different piping. But as long as you have it piped up so that the steam coming out can get to the condenser and the steam coming out of the boiler can get into the pistons, you're good to go. Next thing we're going to do is we're going to have to move our generator over a little bit, and we're going to hook this in. So with 2 pistons, this will be strong enough to get started, likely. If it isn't, we'll put a clutch between the generator and this system so that it has a little bit of less resistance. It all depends on how much force you have going here. So that's going to plug right in. Now, we will gear this up. So what I'm going to do here is, now if the arrow of the gear is pointed towards the source of power, in this case, steam pistons, that's going to increase RPS. That gives us more power. So I'm just going to go ahead and we'll do 3 generators. And I'll show you how this behaves. So we'll just go and we'll go all the way to, we'll do 1, 1. We'll go to 3, 1, 1, 1, 3, 1, 1, 1, 3, 1. And we're going to do 3 toggles. All right, so toggle 1, 2, and 3. That'll be for our 3 different gearboxes. So this is going to allow us to get a 3 to 1. Then we'll select the next one. That'll be a 9 to 1. We'll select the last one. That'll be a 27 to 1 gear ratio. So for every 1 rotation of these pistons, we're going to get 27 rotations of the generator. That's going to give us some better power generation numbers. So next thing we need to do is we need to make a microcontroller to work the valves in this. All right, so from the example there, if we remember when I was moving with the electric motor, when the piston is all the way at the top, that is 0. As it comes down all the way to the bottom, that is 0.5. From 0.5 all the way back up to the top is 0.5 to 1. So it's 0 to 0.5, 0.5 to 1. So the downstroke is 0 to 0.5, the upstroke 0.5 to 1. So what I'm going to do is, I think this is the best method, so I'm going to just grab a blank microcontroller and I'm going to stick it on top here. All right, so what I want to do here is I'm going to click on my microcontroller, and we're going to use those numbers to make some auto valves here. And so we need to do, the first one here is going to be a number input. That's going to be piston position. And this is going to report the position of the piston. And the next one's going to be an on-off output. That's going to be down. So when the piston is going down, we want to orient 2 of the valves to be open so that it will help facilitate that piston going down. Next, we want to do an output here. This is going to be up. So this will control 2 of the valves to make sure the piston is going up. So we'll go in there. All right, really simple. So down is going to be 0 to 0.5. So we take a threshold, and from 0 to 0.5, we want the valves open that are associated with going down on the piston. All right, so we're going to grab another threshold. When we're going from 0.5 to 1, we want the up valves to be oriented. So that's very simple and done. So this is the way I like to do it. I like to do one of these microcontrollers. I accidentally deleted a valve, so I'll just replace it. So I like to do one of these microcontrollers for each of my pistons. This just makes it really super duper simple so that it always works the timing for that particular piston. So what we'll do here is we'll hook this one up. So here's the piston position, goes to the piston position. This one's going to be down. Remember, when the piston is going down, the steam needs to flow in the top. It needs to also flow at the bottom. So the steam comes in, it goes in, it pushes the plate down, and any air in here needs to be pushed out, right? You need to get rid of the air so the piston can come down. You have nice compressed air up top. You need to let any compressed air out so that this creates a partial vacuum. This creates a high pressure area. Then when it goes back up, we want to put some steam in the bottom. That's going to expand and create a high pressure area. This, because this valve is open, is now the low pressure area. So this pushes the piston back up and pushes that out. So on the upstroke, we do bottom, top. And on the downstroke, we do top, bottom. Very simple. Now, the nice thing with this is it doesn't really matter the orientation of our pistons because we're doing 1 microcontroller per. And so by doing it this way, where we have 1 little microcontroller per piston, it allows us to put as many pistons as we want, and the valve timing is always correct. So down is top, bottom, and up is going to be bottom, top. Very simple. So we could string as many pistons along as we wanted, and by using these microcontrollers, it will control each piston independently. All right, so for example, let's say we want to set our timing. Let's just do, we'll move them a little bit. So let's go negative 0.5, and let's do negative 0.25 here. All right, so let's look at that orientation, as you can see. most of the orientations are going to work. It's all based on valve timing. At all points, there is always pressure. This steam is constantly working. Some of the systems that don't use valves, you have to get the timing right on the pistons. You really don't on this. They will continually push the entire time. This is constant pressure. All right, so we're going to go ahead and quickly connect all the electricity here. I connect all the electricity to my gear buttons. I'm connecting all the electricity to the valves. Make sure you don't forget to do that or you're going to be in trouble. Let's see, we need to hook this. Yep, that's all set, and I think we're good. So let's go ahead and let's spawn it. All right, we'll press the button. We'll get this going. So again, this was the same one from part 3, and I'll check back with you guys as we approach 100 degrees. All right, here we are. We're 5 degrees away from making steam, and here we go. So starting up. You see the pressure is building there. We're converting that water into steam. You can see that it is passing pressure atmospheres into the pistons, and there they go. Now, we have constant power from these pistons. You notice we don't really need to screw around with the timing. They could be both at the same timing. It doesn't matter. Because we're controlling valve timing, we don't need to worry about piston timing. This is not a diesel engine. This is not a gasoline engine. We don't have to tie in the exhaust stroke of one cylinder with the power stroke of the other. These are always on power stroke. There is always compressed steam coming in either the top or the bottom. So it really doesn't matter the timing of the orientation of where the pistons are timed. It matters the valve timing. And so if we look there, we're making a steady 3.7-ish, 8-ish RPS. All right, now let's look at our generator. As you can see, our generator is pretty stable, around 15, 16 S-watts. That's because we're turning at 3.7 RPS. If we click our first toggle button, it's going to start putting load in the system, and it's going to be spinning the generator faster. But that will also create back pressure. That will create load on the pistons. The pistons will slow down, but it will now create more on the generator. So as you can see here, we went from about a 3.6 RPS down to around a 3 because we put some back pressure on. But we've gone from, let's see, what was it before? It was about 12 S-watts, and now we're up to about 100 S-watts. Let's put another one. So now we're at a 9-to-1 gear ratio. We've slowed the pistons down to 2.5 RPS. These pistons have incredible amounts of torque. We're at 586 S-watts. The turbine system that we were using, everything else was the same on the turbines. Same power plant, same boiler, same condenser, all the same. You notice we're making a lot more power. On the other system, I think it was 445. We're now making 586. Let's click one more time. Now we're going to go to a 27-to-1 gear ratio. You'll notice the pistons are going to slow way down. We're down to 1.15-ish RPS. We're up to 860-something S-watts. Now, eventually you're going to get to the point where the pistons are just not going to be powerful enough. If increasing the same thing with gearing all the time, if you've ever watched any of my gearing tutorials, if increasing the gear ratio causes the, I usually say speed, but in this case, the power generation to go down, you need more power. So you'll eventually get to a point where if you ever increase the gear ratio more, it's actually going to give you less power. And so at that point, you need more. It's going to give you less, in this case, power generation. You need a more powerful piston system. But as you can see here, very powerful, these steam pistons. We have 2 steam pistons, and they're giving us 800 S-watts. All right, so let's go ahead and very quickly, we're going to add a couple more pistons. This system is very, very easy to work with. All right, so back in the editor here, we'll do our final thing. We'll add a couple more pistons. We'll start to make this engine more powerful. So we're up to something like 860 S-watts. So let's go ahead and push this sucker back just a sec. We won't even bother merging it yet. What we'll do here now is I'm going to grab from this steam port there all the way up to about there, I would say. And let's copy this. Let's make sure we get the piston too. All right, we'll copy this, and we'll move it over here. All right, and we'll paste it, and we'll merge that up. We'll grab the generator and all its accoutrements, and we'll push that back up against the pistons, and we'll merge it up. So now we've doubled the power theoretically, of the engine. The issue being this is if we, for example, cannot make enough steam to feed for, we're going to need a bigger system. So let's test it. Let's see. I'm not even sure myself. We need to hook the electricity up. All right, electricity is all hooked up here. Beautiful. All right, so next thing we're going to do is, again, piston orientation should not matter. And the reason, again, it should not matter is the valve timing is giving us constant power. So it doesn't really matter. We're always having steam pushing on one side of the piston, and we have steam pushing on the other side of the piston. It doesn't matter. The steam is always getting the pistons moving. But if you want to give it a cooler look, we can do... that is at a negative 0.5. That is at a 0.25. Let's go a 0. Let's go a positive 2.5 here. So we'll set that orientation up there. As you can see, that gives us a nice kind of a cascade look to it. All right, good. So let's get the steam plugged in here. So we'll cut over here, and we'll put a T-piece on. Beautiful. All right, so this side should be all set. Let's go over here. This side is going to be a little bit different because of the way I have this set up. And so we're going to have to flip some stuff around. Not a big deal. We're going to cut that, cut that, cut that, and cut that. All right, we're going to go ahead and we can grab some parts here. So we're going to grab one of these elbows. Probably could have flipped it, but we'll do it manually. So that like that. Again, I want my steam to flow in one direction. So we're going to go like this. And I don't know if this is necessarily critical to have on here, but it's nice to have. It's just peace of mind. Your steam is going to go in one direction, and you want your pressurized steam, whatever it is, air, to go in the path of least resistance. So that's why I'm doing valves. So as you can see, it will come out of these, go this direction, down in the condenser. It will come out of these, go this direction, go down in the condenser. So let's test out this system. This system should be stronger unless we run out of steam. All right, here we are approaching 100 degrees. We're at 97 degrees and climbing. Here comes the steam. So steam pressure is building. Eventually, the pressure is going to be big enough to overcome the static force of the pistons being stopped. Remember, an object at rest wants to stay at rest. An object in motion will stay in motion. So it's going to require some steam to get these moving. There they go. Now they are moving. They want to stay moving. So as you notice here, it doesn't really matter the actual timing of the pistons themselves because the valves are doing all the timing for us. We don't need to do the timing of both. We're at 3.8. Now notice the RPS is the same as the first test, right? Around the same. That's to be expected. What's going to change is this is more powerful, and because this is more powerful, what it's going to allow us to do is move a larger mass here. So notice, we're around 8 something last time. Now we're able to go up to 1100 S-watts. And the reason we can do 1100 S-watts is we've made our engine, our motor, our power plant larger. And so now, as you can see, we're doing 31 RPS here. We're down to 1.2 RPS over here. We're able to turn this generator even faster here. The resistance, the back pressure of this generator is not slowing our pistons down as much because the pistons are more numerous, more massive. It is the back pressure of the generator is not as much. So as you can see with this system, we have 4 pistons here. We're making 1128-ish S-watts. With the turbine system, we were making 445. So if you need to make a lot of power, this will do it. I think I can get something like 1024 with a diesel 3x3 running at about 10 RPS. So as you can see, this is a pretty effective system here. So hope you guys found that informative and helpful, and I will see you guys in the next one.